Now we want to see how we can draw any angles in a standard position. So to draw angles, you need to know that that angle is how many revolutions. You know that a full revolution in any um, circle is 2 pi, which is a full revolution. So for one revolution, we have 2 pi radian. But if we have 3/4 of revolution, that means if you multiply 3/4 by 2 pi, gives you 3 pi over 2. And 3/4 of revolution means 1/4, 2/4, 3/4 is over here. That means this point is 3 pi over 2 in radian. If I have half a revolution is just this. And if I multiply 1/2 by 2 pi, which is a full revolution, I get pi. So that means this point is pi. And 1/4 revolution, which is this over here, and if you multiply 1/4 by 2 pi, gives you pi over 2. So by having an angle in radian, you can see that how many revolution we have to graph or draw that angle in standard position. For example, it says draw and label this angle in a standard position. So the angle is negative pi over 4 in radian. So first of all, when you see an angle is negative, it reminds you that you need to go clockwise instead of counterclockwise. And you know, for all angles, the initial side is the positive side of the x-axis. So from this line, you need to go in clockwise, which is this side. Now you need to know how much you have, how much is that angle? How much is pi over 4? Or how many revolution, what fraction of a full revolution you need to pass? So pi over 4, the question is pi over 4 is what fraction of a full revolution, which is 2 pi? And the answer is 1/8. So it's 1/8 revolution. Because if you multiply 1/8 by 2 pi, it gives you pi over 4. And you know that 1/8 revolution means if you divide this whole coordinate plane by 8 in 8 parts, so 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, which is the full revolution. But in negative direction, that's 1/8. So we only go 1/8 of revolution in negative direction, and it gives us pi over 4. Next angle is 3 pi over 4. So 3 pi over 4, it's positive, first of all. Positive means we need to go counterclockwise. But we need to find 3 pi over 4 is what fraction of a full revolution. So 3 pi over 4, you want to see 3 pi over what fraction of 2 pi is this? And the answer is 3/8. Because 3 times 2 pi is 6 pi, and divide by 8 gives you 3 pi. Is 6 pi over 8, which is 3 pi over 4. So you have 3/8 revolutions. That means if you have the whole coordinate plane in 8 parts, 3/8 means 1/8, 2/8, 3/8. So it's over here. So that's your angle. That's the initial side, and that's the terminal side. In this picture, you can see all of the angles, both in positive and negative direction. In this picture, you have all positive directions, which is counterclockwise. You can see all the angles in degree and radian, which means the first one is 30 degree, which means pi over 6 radians, 45 degree, which is pi over 4 radians, and you have all the angles for full rotation. And in the second picture, you have it in negative direction. So in negative direction, clockwise direction, we have negative 30, which is negative pi over 6. We have negative 45, which is negative pi over 4. Which means if I have this point on the circle, this point in a positive direction is 150 degree, but in negative direction is negative 210 degree. So that's why it's important that you know that how you find angles. If it's negative, you go clockwise. If it's positive, you go counterclockwise. And how many rotation you need to go for finding that angle. And in these tables, you can also see the number of revolutions. For example, if we have 112 revolution, that means we have pi over 6 in radian, which is 30 degree in degree form. If we have 1/8 revolution, 1/8 times 2 pi is pi over 4 radians, which is 45 degree. And you can see all of the angles in degree and radians based on the number of revolutions on these tables. Now we want to know what are coterminal angles. Coterminal angles are the angles that have the same initial and the same terminal sides. For example, I have a circle and I have an angle over here. That's my initial, that's my terminal. That's angle. If I want to find a coterminal angle for this angle, I have different options. I can find a negative angle, which is coterminal with this angle, because if I go in negative direction, I can find another angle, which has the same initial and the same terminal side with that angle, but in negative direction. I can also find another coterminal angle, which has more than one rotation. For example, if I start from the initial side and I pass one rotation and get back to this point, I still have the same initial and the same terminal side, like this one. So this angle is also a coterminal angle. But you know this angle is above 360 because we passed one rotation. So to find coterminal angles, what do? We just add or subtract that angle with the multiples of 360 if it's in degree, or multiples of 2 pi if it's in radian. When I say multiples of 360, means adding by 1 360 or 200 360 or 300 360, or subtract 1 360, 2 360, 4 360. It depends what type of coterminal angle you want to find. You want to find it positive form, you want to find it in negative form, you want to find it in the first rotation or in the second rotation. It depends on where the coterminal angle is. So we can find as many as coterminal angles for every angle. Because you know, in trigonometry, we can have, for angles, we can have as many rotation as we want. For example, in this example, it says, assume we have a 400-degree angle. It's in a standard position. And you want to find a positive angle, which is less than 360. And that's coterminal with this angle. So we want to find a coterminal angle for 400-degree angle, but we need to know that it should be a positive and less than 360. So if I want to show 400-degree angle, 400-degree angle starting with the initial side, but you know that's more than 360. So that means you have a full rotation, which is 360, and 40 more. That's the 400-degree angle. Now, if you want to find the coterminal angle, that means you want to find an angle which it has a same initial and the same terminal side, but it should be positive and less than 360, which is this angle. How much is this angle? Yes, it's 40 degrees. So how we can find that answer? By just subtracting 400 by 360 degrees. As I said, you need to add or subtract by 360 or multiples of 360. Next example. Now this time we want to find the coterminal angle for negative 135-degree angle. If I want to show negative 135-degree angle, since it's negative, I need to go clockwise, and it's somewhere over here. So that's my initial and that's my terminal. That's negative 135. If you want to find a coterminal angle which has the same initial and same terminal side with this angle, but in the positive direction, that means you want to find this angle. How we can find that angle? This time, since the angle is negative, we need to add by 360. And if you add by 360, you get the positive angle, which is less than 360. So remember, if your angle is above 360, subtract by 360, and if it's negative, add by 360 to get it positive. You want to find a positive coterminal angle. Now, in next example, we have angles in radian. That's the same. Again, you need to find where the angle is. 35 over 5, 30 pi over 5. So you know that one full rotation is 2 pi. And 2 pi is 10 pi over 5. That's right, because 10 divided by 5 is 2. But your angle is 13 pi over 5, sorry. It's 13 pi over 5. That means it's more than one rotation, is above, is more than 2 pi. So that means your angle is something like this. Okay? So since the angle is more than 360 or more than 2 pi, we need to subtract 2 pi from that angle. And if you subtract 2 pi from 13 pi over 5, you get 3 pi over 5, which is the coterminal angle less than 2 pi, and it's positive. Next example, we have an angle, a negative pi over 15 angle. Negative pi over 15 means it's somewhere over here. You want to find a positive and less than 2 pi. Since we have a negative angle, this time we need to add by 2 pi. And if you add it by 2 pi and you find the common denominator, you get 29 pi over 15, which is this angle. And that's a coterminal angle with our angle. Okay, now let's go back to the radian measurement. If you remember, we talked about the radian measurement of any angle, and we said that the radian measure of any angle is coming by dividing the length of the intercepted arc by radius of the circle. Now, if we want to find, if there is any example and they ask us to find the length of the arc, we can use the same formula by just multiplying these two. So S is equal to R times theta. R is the radius of the circle, theta is the angle, and S is the arc length, the length of the arc, the length of the intercepted arc by that angle. But something that's important in this case, you need to know that the theta or the angle in this formula must be always in radians. We are not going to replace any degrees in the formulas. And that's a common mistake. So remember, theta, the angle must be in radians. If it's in radian, you replace it into the formula. If it's in degree, convert it to radian first and then replace it into the formula. So this is not a new formula. This is the same formula that we had for finding the radian measure of any angle, but this time using the same formula to find the arc length. For example, it says a circle has a radius of 6 inches. We have a circle which the radius is 6. Find the length of the arc intercepted by a central angle of 45 degrees. If I have a 45-degree angle, I want to find the length of this arc. Okay, the length of the arc is S equal R theta. But I know the data that I'm replacing into this formula must be in radian. But right now, my angle is in degree. So what do? We need to convert it to radian. How do we convert 45 degree into radian? By multiplying by pi over 180. And if you multiply by pi over 180, you get pi over 4. So 45 degree is pi over 4 radian. Now it's ready to replace for data. So for data, you replace pi over 4. For r, which is the radius of the circle, you replace 6. And the answer is 6 pi over 4, which is 4.71 inches. So as you see in this example, it says express the arc length in terms of pi, which is that part, and then round your answer to 2 decimal places. So you need to use the calculator with the pi key on the calculator and find the answer in 2 decimal places. Let's look at another example. We have a circle that has a radius of 8 feet. We have a circle, the radius is 8 feet. Find the length of the arc intercepted by a central angle of 225. So that's 225 degree angle. We want to find the length of this arc, this part. Okay. How do we find the arc length? S equal R data. But data must be in radian. So we need to convert 225 in radian first. So S is equal to R data, but data is in degree, must be converted into radian by multiplying by pi over 180. And if I multiply that by pi over 180 and simplify 225 by 180, which means dividing by 5 and then divided by 9, we get 5 pi over 4. Now we can replace it into the formula. R is 8 feet multiplied by the data, which is 5 pi over 4. And if I multiply them, we get 40 pi over 4, which is 10 pi. If I want to show in terms of pi, I'm done. But if I want to round your answer to 2 decimal place, I need to use the calculator and multiply 10 by the pi key, and the answer would be 31.42 if I round it to 2 decimal digits. And don't forget the unit, which is feet. The unit is based on the unit of the radius of the circle. So now we want to see if we have a central angle inside of a circle, like this angle. So far we learned how to find the length of this arc, which is S. Now we want to see how we can find the area of this sector. So the area of the sector in any circle which the sector is formed by the central angle, it's coming by this formula. That means multiply 1/2 by the r squared, which is the radius of the circle, and multiplied by data, which is the central angle. Again, don't forget that the angle in this case must be in radian again. I'm not going to replace any degrees into this formula. And if you look at the next example, it says a circle has a radius of 4 feet. So the r is 4. Find the area of the circle formed by a central angle of 60 degrees. So first of all, we need to convert the 60 degree into radian, which is pi over 3. Then we have a formula. Formula is A equal 1/2 r squared data. Replace the numbers into the formula. So 1/2 r, which is the radius, is 4 feet, and then multiply by data. If we s square 4, we get 16. 16 times pi on top, 2 times 3, which is 6 at the bottom. And if we simplify, we get 8 pi over 3. But the unit in this case is s square feet, because you had the feet, which you s squared that over here. So now the unit is s square feet. So the area of that sector is 8.38 square feet. Okay, now let's get familiar with the definition of two different speeds, which is called the linear speed and the angular speed. The linear speed, it's a rate at which an object distance change over time. But the angular speed is the rate which an object's angle change over time. So that's a difference. Both of them are the rates. Linear speed is a rate which the distance of the object change over time, but the angular speed is the rate at the object's angle changes over time. We show the linear speed by the letter V. It comes by s divided by t. S means the arc length, divided by the t, which is time. But the angular speed gives us the rate at which the angle of the object change. So we divide the angle, the radian measure of the angle, divided by t, which is time. And this is called omega. This is not W, it's omega, the Greek letter. Okay? So the linear speed, or V, is s over t, change object's distance change over time. Angular speed, it's theta over t, with the object's angle change over time. Now, if we want to have a linear speed by having an angular speed, we can use this formula. So anytime you have the angular speed and you want to find the linear speed, you use this formula. V is just the linear speed, angular speed, and r is the radius, or the distance from the center, which is a kind of radius in the examples. Let's look at an example. It says, long before digital downloads with superb idea quality, individual songs were delivered on 75 RPM and 45 RPM circular records. A 45 RPM record has an angular speed of 45 revolutions. Angular speed, it's omega. Omega is 45 revolutions per minute. Find the linear speed in inches per minute at the point where the needle is 1 inches from the center. 1 inches from the center means the R is the radius. Okay. I have the angular speed, and I want to find the linear speed. So we have the formula. The formula says that the V is R times omega. That's right. But if you want to replace number for omega, for the angular speed, you need to make sure that the units are matches with the units that you want to find for the angular speed, for the linear speed and the radius. Right now, the angular speed is based on the revolution. I want to change the revolution in radian first. I need it, instead of having a revolution per minute, having a radian per minute. And how we can do that? We can multiply it by 2 pi. Or you can say we have 45 revolution per minute multiplied by another fraction, and that fraction says every one revolution is 2 pi radian. Then you can cancel the revolution by revolution and multiply the numerators by the denominator, then divided by the denominator. So 45 revolution per minute means 90 pi radian per minute. After changing the angular speed to radian, now you are allowed to replace it into the formula. And replace the omega by 90 pi, replace the r by 1.5, and the answer is 135 pi inches per minute. And if you use the calculator, replace the pi by 3.14, you get 424 inches per minute. And the next example is that the Ferris wheel has a radius of 25 feet. So the radius is 25 feet. The wheel is rotating at 2 revolutions per minute. 2 revolutions per minute means the angular speed is 2 revolutions. Here, 1 minute. Okay. Find the linear speed in feet per minute. The unit must be feet per minute of a seat on this Ferris wheel. Okay, when you have angular speed in revolution, you need to multiply it by 2 pi over 1, because 1 revolution means 2 pi radian. Then you can cancel revolutions, and the angular speed is 2 times 2 pi, which is 4 pi radian per minute. Now, after changing, converting to radian, now we can use our formula, which is r times omega. So v, or the linear speed, is r times omega. R is this radius, which is 25 feet. Omega, which is 4 pi radian per minute. And if you multiply these two, it gives you 100 pi feet per minute. And if you replace the pi by 3.14 and use the pi key, you will get 31, let me see, 100 times pi, which is 314.16 feet per minute. So the linear speed is 314 feet per minute.